question is where were we wrong? Can anyone want to try before we discuss the answer? Where exactly we are wrong? So this we were doing this type of calculations, okay, which seemed very simple, but we got a strange answer, the 0 equal to 1. Is the calculations clear to everyone? Are the calculations clear to everyone? Are you there?
Yes.
Okay. So any guess you want to guess that where would be the mistake?
Sir, we were calculating the values of V1 and V2 based on a value of E, I mean closed surface integral E dot dl at
Any instant of time. Yes, true.
any instant on time.
And
But here,
everything is for that instant of time only. We are not interested what happens before or after. Whatever calculation it is that very instant of time. Not before, not after. Not after.
sir, but if this part is constant, then without the changing flux, there will be no current.
No. Current will be there. At a given instant of time, there will be some current because flux is changing. The current will also change with time. Actually,
Okay,
no.
sir.
Actually, it will not change because because the E was. It depends on how the flux changes. Actually, it depends on how the flux changes. The flux changes. If the flux changes, say near linear, then there will be no change. Only at that instant. Next instant it will be something else. We are not interested. Or the instant before there will be something else. We are not interested. We are interested in that particular instant only, where this generated induced EMF is 1 volt. We are not interested what happens after or before. Okay. I am not saying that this value 0.1 value will be throughout. It will, of course, it may change. We are not interested. Again, that is wrong. What is wrong? How do we define potential? Potential was potential was potential. We define potential, right? But how we define potential? Infinity to any point. Yes. We have done from infinity to any point. Or VA minus VB, you are defining, right? So potential difference delta phi was phi 2 minus phi 1. True. And how we are defining potential? We are defining potential such that phi we did this. We did this.
Yes, sir.
So what will be this?
0.
0. But right now, for a change in time varying magnetic field, we saw that. Oh, we didn't see actually. Okay. Integral of EDL equal to ddt of BDS, right? We started with Faraday's. This is Faraday's law. Is this Faraday's law? We started with that. minus d phi by dt? Yes or no?
Yes, sir.
Different. Now,
Yes, sir.
if we use Stokes theorem here, from Stokes theorem, integral of EDL is what? Right? Is it right? Is it correct? Stokes theorem? Or is it okay? Combining this and this? Is it okay? Is it okay or not?
Yes, sir. Okay.
Usually, now, B can also vary with X, Y, and Z. Is possible. So, to insist on the time varying, we usually write it not as D, but del. Okay? Because B can be functions of X, Y, Z also. So, we write curl of equal to del B by del, not dB by del. Is it okay? So, this type of a definition is correct. This type of definition is correct only when curl of E is 0 or integral E dot dl is 0. You get the point? This type of thing is correct only when closed integral of E dot dl is 0. What does that mean? What does that mean? That if we move from one point and come back to another point, to the same point, then the work done EDL is 0. Is it okay?
Yes, sir.
Or phi A minus phi A is 0.
Yes,
Right?
sir.
2 points must be in the same potential. Yes or no?
Yes, sir.
Okay. But what is happening here? Here, curl of E, that is equal to minus del B by del T, that is not 0. Is it true or not?
Yes, sir.
So here, integral of E dot dl is not 0. Or if we move from one point to the same point, the change in potential will not be 0. So here, what we are saying that this integral is now path dependent. It can have two values at two different times. You understand the problem? This EDL is path dependent because integral of EDL is no longer conservative. Did you get the point or you want to? Is it okay or not? Is it okay or not? Right? Because as we had seen, for conservative fields, integral EDL should be 0 for conservative fields. However, here integral E dot dl, that is not 0. That is equal to minus d phi by dt. And if you see this 1 volt, multiplying with 1, this is incidentally same as PDL. So we cannot define potentials like that, and VA minus VT can be very different for two different paths. Because here there is a time varying magnetic field which is making the electric field non-conservative. Is it okay or not? Is it fine? So KVL or Kirchhoff's voltage law is not applicable for the cases when there are time varying magnetic fields. Correct? Any questions? Ask me. Any questions? You are welcome to
Please
ask.
repeat the last part.
His KVL or Kirchhoff's voltage law is not applicable in the situations where there are time varying fields. Because KVL always expects that the closed integral of ED or EL will be 0. However, for time varying magnetic fields, closed integral of EDL is equal to minus d phi by dt as per Faraday's law. If B is constant with time or phi is constant with time, then d phi by dt is 0 and E dot closed integral of E dot dl is 0 as per KVL. You get the point? Get the point? All of you must watch Professor Lewin's lecture where he demonstrates this, right? I just did by mathematics. He demonstrates this with actual voltmeter, actual circuits and everything. He shows the readings and he indeed proves that the two voltmeters make different effects. He shows us and then he proves us. I will give you the lectures and I request all of you to see the lecture. See the full lecture. It's 1 hour lecture, but it is what much. Okay? Because there you will see the actual demonstration of this. What I told you, because I do not have those, but whatever I told you and whatever I solved using every example I have given, they are taken straight from that lecture. Okay, it's 1 hour lecture, but it is worth seeing. Anything else? Is this concept okay? Is this concept okay? Is it okay or not?
Yes, sir.
Okay, thank you. Next. So, as per Faraday's law, we had seen that a time varying magnetic field it generates an electric field. Yes or no? This is Faraday's law. Point form. So opposite. So we can expect the opposite. A time varying electric field should generate a magnetic field. Can we expect the opposite? The time varying electric field it will generate a magnetic field. But the problem is we have only this. J does not have to be time varying. Even if J is constant with time, we still get an H. Just we saw in the last classes. We found the H, right? There are more problems. What is this? This should be the case. If this is true, then this must also be true. You can take divergence of both sides. Yes or no? Yes or no? You can take divergence of both sides. Possible or not? Possible or not? Right? What is this?
0.
0. What is this? We are discussing the class. Is it 0 as well or something else? We discuss in the class.
Curl of H.
Part of my divergence of a vector is a scalar and curl of a vector is a vector. So a scalar cannot be equal to a vector. This cannot be curl of anything. I by A is J.
0.
I
0.
by not 0. No. At least not in the general case. Had it been 0, then
ddt
there had
of
been no
rho.
problem. It would be satisfied. Sorry?
ddt of rho.
ddt of rho. Rather minus ddt of rho. Check. And then there is a name of that equation. What is it called? This equation, it's a name. What does it call? What this is called?
Equation of continuity.
Equation of continuity. Very good. So when if there is a change del t of rho, then this equation doesn't hold. If del t of rho is not 0, then this equation doesn't hold. Right? There is a problem. So what it was suggested that let us say curl of H is J plus some another vector N. We do not know what it is. Okay? We take divergence of both sides. We can. This is 0 as you rightly said. This is del rho del t and we do not know this because N is unknown. Okay? Correct or not? Correct or not? So this can be written. This can be written. Yes or no?
Yes.
Hmm? Does
Yes.
this equation look familiar? What is this? This is divergence of something. Sounds familiar? Have you heard seen this anywhere? No. It's some divergence of something. Can you recall what? This rho is divergence of something. Can you recall what? D. Very good. Or look. Is it okay? Is it okay?
Yes, sir.
Look, this is not a proof in the strict sense. We have not proven it. But this is taken everywhere and so far nothing has been found contradictory to this. So combining this displacement current, this is the displacement current density. So curl of H is equal to JC. This C is the conduction current which were there from the Ampere's law, and this term explained by Maxwell, added by Maxwell, is JD. JC is sometimes as sigma E and JD as we are just saying. Is it okay?
Sir, displacement current density is an axiom.
axiom. Actually,
You just
uh, it has not been proved. This law, it has not been proved by anyone in strict sense. However, this nothing in the world has been found so far which contradicts this. So we accept it. So you can say, but it doesn't mean that it cannot be proved in the future. Some in future maybe somebody is able to. That person is very likely to get a Nobel Prize. Hypothesis. Maybe. Okay. So let us summarize whatever we have learned and we will close for the day. Maxwell's equation. What is this called? What is this called? What is this called? What is this called? We discussed this now. What is this law called?
Faraday's law.
Faraday's law. Yes. What is this called? What is this called? You surely know this.
Maxwell's law.
Actually, it's Ampere's law with Maxwell's connection. Okay? Not Maxwell's law. Ampere's law with Maxwell's connection. Or just Ampere's law. Third. What is this? Yeah, Maxwell. What is this? This also we have discussed many times, including yes, last class Saturday. What is this, my friends? What is this law called? Okay, let us we'll see that later. What is this? What is this law called?
The Gauss law.
Gauss law. Okay. So what is the upper one called? What is this
The
one called?
Gauss law of
Gauss law of
magnetism.
magnetism. Very good. Now let's say these four equations are the four Maxwell's equations. Usually we consider surfaces of volumes where there is no charge. So usually we take divergence of V to be 0 when there is no charge. Okay, no enclosed charges. If there are no enclosed charges, then this will be 0. Okay, so usually we take that divergence of V is 0. But if there is at the enclosed charge, we have to take this 0. Next step, same equations in integral. Maxwell's equations in integral. We had seen how it is derived. Hmm? Second one, what this will be? What will be the right hand side? What will be in the right hand side? What will be the right hand side? That is IC plus IB. That is JDS plus del T Okay. So there are this time there will be two homeworks. Homework 1, proof. Using the point form, prove the integral form. The conversion from point form to the integral form or from integral to point form, both are very important for the ES examinations. If the ES examination is in written form, not by online, then there will be at least one question where you will asked to prove equations from either point form to the integral form or from integral form to the point form. Is it okay? So your first homework is prove this. From the Ampere's law to the point form, derive the corresponding version of the integral. Third, Gauss law mechanism, B, ds that is 0, and Gauss law of ds that is equal to. Are these okay? Are these okay? Of course, there will be an L here, A here, this here, this here, this here. Are these okay? Please repeat the HW. Oh, homework. There are two homeworks. First homework is starting from this equation, prove this equation. Okay. So this is the first homework. Second homework I will give you after this class. Is this okay?
Yes, sir.
Okay. Any other question? Solve problems. Some problems I have already given you in assignments. You can solve them. As well as solve any take any book on electrical, you find plenty of problems. Due to lack of time in the class, I always do not have get the time to solve more problems. But you must solve very problems because I have already keep on mentioning 50% of the marks in any exam, be it NT or ESA, doesn't matter. 50% of the marks will be from problems. So if you are not solving problems, you will be in trouble because this subject is not the one like those which you will study, cram up in the day before exam and pass. Okay, as you can see, this subject you need this conceptual paper and you have to study from day one, practice on from day one. So solve problems. Anything else? Any questions before I wrap up for the day? Any question? No? Okay then, thank you.